Hey everyone, and welcome back for another deep dive.
Ready to go deep.
Always. You know how this works. We take a stack of research, articles, whatever's got us curious, and we pull out the absolute must-knows.
The need-to-know info.
Exactly. And today,
We're going cosmic.
full-on cosmic, exploring the chemistry of Uranus and Neptune, those icy enigmas way out there.
Often overshadowed by the gas giants, but their chemistry is wild. Think diamond rain, tilted axes, and the works.
Okay, so first things first, why even call them ice giants? I mean, they're so far from the sun, gotta be freezing, but is it just about temperature?
It's more about what they're made of. Unlike Jupiter and Saturn, which are mostly hydrogen and helium, Uranus and Neptune have way more heavier elements. Oxygen, nitrogen, carbon. But here's the thing.
What's the thing?
They're not gases at those distances. They form ices.
Hold up, so like skating rink ice. Are we talking giant hockey puck up there?
Not quite. We're talking methane ice, ammonia ice, water ice, all swirling around under immense pressure.
So not our typical ice cubes, got it. But all that ice, that's got to make them super dense, right?
Absolutely. It's what makes them so different from anything we experience here on Earth.
Right, so giant slushy planets, check. But what about that color? Both Uranus and Neptune, so strikingly blue.
Ah, yes, the methane atmosphere at work. Methane absorbs red wavelengths of light from the sun.
So it's reflecting the blue back at us.
Exactly. Similar to why our sky's blue, but way more intense because their atmosphere is so methane-rich.
So it's like Earth's sky, but with a supercharged blue filter. Makes sense. Okay, now for the question everyone's thinking diamond rain, is that for real or some sci-fi hype?
It's a captivating possibility. Deep inside those ice giants, the pressure and temperature are so extreme, carbon atoms could actually bond together and form diamonds.
And those diamonds, what, they just fall like rain?
Think of it as diamond rain, yeah. Heavier than the surrounding material, so they would precipitate down towards the planet's core.
Hold on, actual diamonds, like the kind you'd find in, I don't know, jewelry. Theoretically, yeah, scientists are still studying it, but the conditions on Uranus and Neptune make it plausible.
So you're saying there could be diamond storms raging on these planets?
We haven't observed those directly, but it's definitely an intriguing possibility.
Okay, that officially blows my mind. But shifting gears a bit here, Neptune's got this weird heat issue, right? Giving off more energy than it gets from the sun.
You're right, it is a bit of a puzzle. Neptune is farther out than Uranus, but it's radiating more heat.
So what's going on there? Does Neptune have some secret internal furnace we don't know about?
Nothing we've found yet, but scientists believe it's got to do with gravitational contraction, the planet slowly compressing under its own gravity, and possibly radioactive decay within its core.
So Neptune's basically giving off heat as it shrinks, like some kind of cosmic space heater.
You could say that.
And all that internal heat, what does it do to the planet?
It likely drives Neptune's crazy dynamic atmosphere. Those powerful storms, high wind speeds, all that energy has to come from somewhere. Right, because calm is not the first word that comes to mind when you think of Neptune. But speaking of wild, Uranus with that extreme tilt, right? Not just a little lean, it's practically sideways.
Exactly. Uranus's axis is tilted almost 98 degrees, compared to Earth's 23.5.
Wait, so for part of its orbit, one pole is pointed almost directly at the sun.
Exactly. Imagine the kind of seasons that would create.
Yeah, how does that even happen? Did Uranus get knocked over in some planetary billiards game early on?
That's the leading theory, a massive collision early in the solar system's history, a cosmic hit and run.
Talk about a bad day. So what does this do to Uranus, aside from making it look like it's doing a cosmic cartwheel?
It makes for some incredibly strange seasons. Imagine one pole bathed in sunlight for decades, while the other's in darkness.
Wow, so a summer that lasts 42 Earth years, followed by a winter of the same length. That's got to do some weird things to the atmosphere.
Absolutely. It creates a super complex and unpredictable atmospheric environment.
All right, so we've established Uranus and Neptune, not just boring blue balls of gas. They're dynamic worlds, wild chemistry, crazy weather, even the possibility of diamond rain.
And we're just scratching the surface. There's so much more to discover about these ice giants.
And discover we shall. In part 2 of our deep dive, we'll plunge even deeper into the mysteries of these fascinating planets. Stay tuned.
Welcome back to our deep dive into the ice giants. Ready for more?
Absolutely. You had me hooked to diamond rain, but I'm ready to go even deeper. What else have we got on these mysterious planets?
Well, let's move past what we can see and talk about what's hidden deep down. The magnetic fields of Uranus and Neptune are unlike anything else we see in our solar system.
Ooh, magnetic fields. Sounds a little complicated in layman's terms.
Okay, so here on Earth, our magnetic field, it's pretty straightforward, acts like a shield protecting us from solar radiation, and it's why compasses work, pointing north.
Right, Earth's magnetic field is like our personal force field against those nasty solar storms. So what's different about Uranus and Neptune? Do they have like double magnetic fields or something?
It's not about quantity, it's about structure. Their magnetic fields are not neatly aligned with their rotation like Earth's. They're tilted and offset from the planet's center.
So imagine Earth's magnetic field, all wonky and off-kilter. Hey, that would mess with our navigation systems. What causes that kind of weird magnetic field?
Scientists think it's not the planet's cores directly generating the field, but rather a layer of electrically conductive fluid surrounding the core. It's the movement of this fluid that creates those unusual magnetic fields.
So it's like a swirling ocean of electrically charged liquid creating these off-kilter magnetic fields. That's pretty wild. What does that mean for the planets, though?
Well, for one thing, it results in some pretty spectacular auroras.
Wait, auroras, like the northern lights? I thought those were caused by the sun interacting with our atmosphere.
You're right, auroras are caused by charged particles, but on Uranus and Neptune, those particles aren't coming just from the sun. They're generated within the planet's own magnetospheres, shaped by these unusual magnetic fields.
So it's like their internal turbulence is creating these light shows. That's way cooler than our earthly version. What else have these ice giants got hidden away?
Let's talk about their moons. They're not just chunks of rock, they have their own stories to tell. Stories about the formation of these planetary systems.
Okay, moon talk. Hit me with some fascinating moon facts.
For starters, there's incredible diversity. Some are heavily cratered, suggesting a violent past, while others have smooth, icy surfaces hinting at geological activity.
Geologically active moons. Doesn't that mean they could have, wait for it, internal oceans?
You got it. There's strong evidence that some moons, like Neptune's Triton and Uranus's Miranda, could have vast oceans beneath their icy shells.
Okay, hold up. Internal oceans, diamond rain, wonky magnetic fields. These ice giants are way more interesting than they get credit for.
And we haven't even touched on the possibility of life. While Uranus and Neptune themselves are too extreme, those internal ocean and on their moons, they could potentially be habitable environments.
Hold on, are you saying there could be alien life swimming around in those oceans?
It's a fascinating possibility. Scientists are actively investigating. These oceans could contain liquid water, organic molecules, and sources of energy, the building blocks of life as we know it.
So we could have alien whales or glow-in-the-dark jellyfish hanging out in those hidden oceans? My mind is officially blown.
It's definitely exciting, but remember, we haven't found any direct evidence of life yet, but the potential is there, and that's what makes these moons such compelling targets for future exploration.
From boring blue balls of gas to possible cradles of alien life, these ice giants are the underdogs of the solar system.
They certainly are, and there's so much more we're learning about them all the time.
Which is why we need part 3 of this deep dive. Where are we headed next in our exploration of the ice giants?
Next up, we'll journey back to the beginning, exploring the origins of Uranus and Neptune and what they can tell us about the formation of our solar system as a whole.
Okay, we're back, ready to wrap up our ice giant odyssey.
Ready to talk origins?
Absolutely. We've covered some pretty mind-blowing stuff about Uranus and Neptune, but where did they come from in the first place? Were they always those distant, icy enigmas?
That's the million-dollar question, and it takes us to a fascinating theory, planetary migration. The idea is that Uranus and Neptune didn't actually form way out there where we see them now, but much closer to the fore.
Wait, so you're saying these massive planets, they journeyed billions of miles across the solar system. What could possibly cause that kind of planetary relocation?
Well, picture the early solar system, right? It was chaotic, a cosmic billiards game with planets jostling for position.
Bumper cars on a planetary scale.
Exactly, and the gravitational forces from the real heavy hitters, Jupiter and Saturn, those likely played a major role, nudging Uranus and Neptune outwards over time.
So Jupiter and Saturn were like the cosmic bouncers, pushing the smaller ice giants out of the club.
It's less about pushing and more about the laws of physics at play. Gravity is a powerful force, right? And in a system with so many massive objects, these gravitational interactions, they would have had a huge impact on where the planets ended up.
Okay, so picture this. Uranus and Neptune cruising along in the warmer inner solar system, and bam, they get shoved out into the cold, dark depths. That's got to have some consequences.
For sure, this migration likely explains why they've got so much ice compared to the gas giants. As they moved into colder regions of the solar system, all those elements that were gases closer to the sun, things like methane, ammonia, water, they would have condensed into ices.
So their icy composition is like a cosmic souvenir of that relocation. That's amazing. But if they formed closer to the sun, what about their moons? Did they bring them along for the ride, or?
Another great question. There are a couple of possibilities here. Some moons might have formed alongside the planets in their original location, Others could have been captured as the planets migrated outwards, drawn in by their gravity.
So like a cosmic adoption program. Uranus and Neptune scooping up moon souvenirs as they traveled through the solar system.
It's a fun way to think about it, and this capture scenario could explain why some moons have such unusual orbits or tilts, suggests they were caught in this gravitational tug-of-war as the planets were shifting positions.
So we've got planets migrating, moons being adopted. Sounds like the early solar system was a wild place.
It definitely was. And by studying these ice giants and their systems, we're getting clues, right? We're piecing together the history of our solar system, learning about those early days and all the forces that shaped what we see today.
So Uranus and Neptune are like time capsules, offering us a glimpse into the solar system's crazy, chaotic past. And what's even more amazing is that they're still evolving, still changing.
Exactly. Their atmospheres are incredibly dynamic, right? Storms lasting for years, seasons that stretch for decades, and who knows what other secrets are hidden beneath those icy shells.
From diamond rain to hidden oceans, from planetary migration to the possibility of life-bearing moons, we've really gone deep on these ice giants.
And the best part is, we're just getting started.
Exactly. There's so much more to learn and explore. So keep looking up, everyone, because the universe, it's full of surprises. And that's what makes it so fascinating, right? Until next time.